This is the PhET simulation for concentration of solute and solvents. Have the simulation to the right and the paper over to the left. Remember, this goes with the above and beyond, so it is optional. Okay. All right, so did you know a solute is a substance that is dissolved in a solvent to create a solution? The concentration of solutes in a solution can be calculated using the following. Concentration in molarity is moles of solute divided by liters of solution. And the question is, how does doubling the volume of a solvent affect the concentration of the solution? So if you add more, in this case, water, what is it going to do to how strong the solution is? Okay, so here's where you would put your prediction. All right. And now the procedure. Drag the concentration sensor into the liquid. Right there. Add some solid solute to the solvent. It doesn't say how much, so we're just going to throw some in there. Just grab and shake. Shake some of that in there. All right. Record the concentration in your data table. All right, so the concentration, 1.660. Okay. Then use the top spout to double the volume of the solvent. So we're going to crank that, double it. Record the new concentration in the data table. The new concentration is 0.830. Okay. Now divide the concentration after the solvent is added by the concentration before the solvent is added to get the factor by which the concentration changed. All right, so get the calculator, 0.830 divided by 1.660, I get 0.5. Okay. Reset the simulator and repeat steps 1 through 4 with all of the solutes listed on the data table. Okay. Let's put this over here. Switch to cobalt chloride. Shake a bunch in there. All right, so I start with 1.730. Add water. And I get 0.865. Divide those two, 0.865 divided by 1.730, and I get 0.5. Okay. One more time with copper sulfate. Concentration of 1. Add the water. Concentration of 0.5. Okay. That gets me 0.5 again. Okay. And you may get different numbers over here, but these three, they should be the same. So how does doubling the volume of solvent affect the concentration of the solution? Well, the concentration is halved. Okay, so instead of it getting stronger, it's going to get weaker, right? Whenever you add more water, the mix tastes weaker. All right, so we're going to repeat the experiment using solutes already in a solution. So there's a little dropper over here. So we're going to switch to the dropper whenever we do this again. Okay. So drink mix, solution, concentrate, and we do 0.732. Add water. we get 0.422. And we get a much different number, 0.577. Well, it says 100, so 0.58. Okay, well, try that again with cobalt chloride. Drops this in there. Add some of it. 0.634. Add water. 0.377. 0.59. Okay. Now copper sulfate. Try it with this. Drops. Concentration. Put the liquid in. And we get 0.151. Add water. And we get 0.089. So 0.089 divided by 0.151. 0.59. Okay. Now notice that this factor was different than this factor, and it says, why was the factor change less predictable when using a solution instead of a pure solute? Well, the hint is right here. Whenever you're adding this, if you watch the level of the water as you add it, it keeps adding more liquid. And the reason why is because the solution already has a solvent in it, and solvent and solute together. So it's actually two different variables. And you know how in math that your math teachers always say, isolate the variable, isolate the variable. It's the same thing in science. You only want to change one variable, so you want everything else to stay the same. Whenever you're doing this, adding this, you're actually adding two variables. And so that's messing everything up. Okay. It makes it much harder to calculate.